Okay, so today we will try to understand this part that is integrating your GPS data and open data sets. But what basically it means is yesterday we learned that how we can do a survey and basically if instead of mobile or you had something like a GPS lat long. So what a GPS will give you is a lat longs, a latitude, longitude of a point or a line. So it will give you a constant, the spatial location of your point or line. So it is just a vector data. So because we are not into field surveying, but to understand what GPS data is, it is just similar to what we got in Q field, the survey data. So it is based on the mobile GPS. So it has the lat long associated to it. It has the northing or easting associated to it. So now when we have some data that we collected on field survey, how can we how can we kind of integrate or like use other open data set available to us to do analysis. Now, somewhere before uh, we have used USGS. That is that we downloaded, if you remember, we downloaded Landsat 8, 9 imagery. So there is uh, other kind of data sets that are also available in USGS. Just for example, there is the river data set. So that data set is in the form of SHP. It is a vector data set. So just for example, I'll show you how you can get that data. So there are many sources, not just USGS. There are n number of sources where you can find such open data. Any data that you are able to work with for free is by definition called as open data because it is open to everyone for use. So and then we'll also talk about what is OSN. Now, we have been using OpenStreetMap, if you remember. Like there are Google Maps, there is OpenStreetMap. Google lets the common man use its map, but when it comes to business, for example, uh, Blinkit or for example Zepto or Swiggy wants to use Google Maps, so then Google charges them. So then they have to pay to Google for using the same maps that we are using for free in our mobile phones. If you see in Uber, there is a map behind it shows your location where you're going. So actually Uber is paying for that map because they are using it in a commercial way. So similarly, so similarly, there is OpenStreetMap. It is free. You can use it for commercial purpose, anything. It is free and free. But the quality of the data is not so detailed. For example, there might be some streets missing on OpenStreet. So OpenStreet has been developed by people. People contribute, people digitize their own streets and add that data to OpenStreet. So it has been developed by a collaborative effect of many people. So uh, it depends on the person who made it, the quality of that data, how in that area it would be. So first we'll try to kind of maybe do an example of what other open source data that are available to us from maybe USGS. So if you go to USGS and you do a login here, maybe you select the area. For example, I would select because I'm showing how to download a river data, so I'll look for a river maybe. So I can see this river very well. Now what I'm gonna do is use map, narrow down the points to my data set, because there might be minute rivers here also. I don't want that data set, so I'm just narrowing down to it. So I don't select a date range. I just want to have a look all at all the available data sets. So I go to data sets. Here I would choose digital elevation. In digital elevation, we have this SRTM. In SRTM, I would choose this water body data. So similarly, there are many datas around the world. There are many, if you have to explore, you can all explore all of them. So just for now, I'm showing you water body data. Now I go to results. Now I see that because it is done once in a while, like long back. So I have one data that is from 2002. So I will download it. Now once I download it, if I go to my QGIS and I add that vector layer, because the one I downloaded, it is in SHP. So here it is. Now if I add this, so and I take Google Maps as the base map behind. No, not the Google Maps. I'll go to. So because this is from 2002, the river has changed its path. Now, this is a free data set. Like I have a data set, a shapefile of the river. But yeah, the downside it is from 2002. And now you can see how the river moves. But if you are working on a older data, or it doesn't matter to you in a regional scale how the river looks, so now you have a data set. So similarly, you can just download this river data for all of India, all of the world. Just select this complete as your uh, zone of interest, area of interest. You can download it. So this was one example for you to understand that there are different kind of data available at different uh, institutional websites or different sources. Now we will talk about OSM. So just like this USGS, but it is a combination of data sets available here. It has the Landsat, it has water body, it has digital elevation models, it has slope model. Now we have OSM. Now this is OpenStreetMap. So if you zoom to any place, you can see someone has created these maps for all over the world. Like if you see that there is a new building being built, so you can just log in, and there are ways you can just digitize it for yourself and it will be added to it. For example, uh, just let me show you this one thing. Yeah. So I used to live in Sector 19 before, and I added my home here. So whenever you open this, you can see uh, Akshay's home, right? So it is on you, and you can just simply log in and you can add your data. Now, But we need to make use of this data. How can we extract this data? Uh, so in your QGIS, if you select this XYZ tile, do it simultaneously with me, as I say. Just go to your XYZ tile, open the OpenStreetMap. Now take any reference city. I just always choose Chandigarh because it is well planned. It can be used for giving good examples in GIS. So now I go to plugins. First, I need to go to manage and install plugin. Now here I have to look for this quick OSM. You need to install this. So after installing, you'll see it will appear here. This, or also you can find it in here in the vector, the last one. So until now, if anyone has a doubt, please let me know. I want you to do it simultaneously. So open your QGIS, go to plugins, install the plugin called Quick OSM. So once you install, just let me know in the comments that you have done until that. Okay. Uh, so now you uh, open this Quick OSM, click on Quick Query. Now it has two columns. Those columns are called as key and value. So what this means is, to understand it better, you can always click here. Now this is like a dictionary to what this means. So when you click this, um, yeah. So in the getting help section, just click OSM keys and values. So once you click this, you will see here that there is something called as key and there is this value. What this means is, for example, now I want all the highways in this place, all the highways or all the roads. So what I will do is I will choose highway here, highway. So highways can be state highway, national highway. So there is like you have to look in highways for yeah. So the defined values are highway can be a motorway, it can be a trunk, it can be primary, it can be secondary. So these are mostly US kind of classifications, but we work according to it. So each one has its own definition. So if you even go to, for example, maybe the key is called building. So building can be residential or it can be commercial. So it is kind of the subtype of it. Now here, let me choose highway. But in this part, in you can write in Chandigarh in something, but I want it for my map extent. So I would choose here my canvas extent. So that is the area that is currently being viewed in my screen. So I want all highways here. Now I will just press run. Now what is it has done? There is some points also associated with highways that are services belonging to highways, maybe a petrol pump, maybe something else. It is also showing that, but as for me, now they are for not of much use, so I'll remove it. Some associated polygons, maybe it is the National Highway Authority of India or something. So, um, so now you can see I've got like almost all the roads because in US classification we are calling the roads as highways only. But if you choose in the value as primary or secondary, then some of it will show up. See, highway, secondary, unclassified, track, tertiary link. This is the value. So if you would suggest, if you now I've got like 42,000 results. So what this means is selected one. No, where is that one? Zoom to selected. Yeah. So this is what I've selected, and this selected one is. Mhm. So it was a footway that is like inside park, the places where you can walk. So you can see it. It it is, I guess, yeah, it's a park. So there is classified. The data has been kind of classified based on its origin. So now you can look for any kind of data. You can look for schools. For example, if I go there again, maybe I have to check there if school is a value. I don't think so. Building, school. No, military school. So there are different classifications. You have to work on it, like what must be the school in our areas be called. But in case if you just leave it blank, you leave this blank, you select your canvas extent, and you just um, now where is the run button? Yeah, and you just run the query. You just remove this polygon. So now in this case, it has given me all the data, like all the data available within that area. So for now, I can see someone has not made the school. So I can go to OpenStreetMap and create a school. So that data will be also added to this. Now someone has added this point, that is Hotel Park View. So different kind of data sets are available. So, for example, if you need to be working with the data of the roads of this city, so if your boss says, okay, do it now, for you it's really easy. You just go to OpenStreetMap and you just have to look if the data is available and you can find it for free. So you don't have to um, like work around it to digitize it. So even there is options to download the boundaries of the country, so the country, the states. So maybe boundary is equal to administrator. So I choose boundary is equal to administrative. Now you can see I have some of the district boundaries. So I didn't have to go and look. Now I have the boundary of Chandigarh here. See how useful it can be. I have the boundary of the sector wise of Panchkula. So this is one source of, I think, the biggest source for open data, that is the OpenStreetMaps. So I told you one way how to download it. Now, in case you don't have QGIS in your computer and you need your data, or you could just simply go here, log in, select the area. There is an option to select the area, and you can just directly download it here also, and then open in your QGIS. So you get the option here also. Now, until now, please let me know if you are clear about what OpenStreet data is and how to download it, right? Okay. Now there is something called as overlays. What is overlay? So for example, you have a boundary of forest. This is some boundary of forest, but you have a polygon. You have a polygon of it. It can be, maybe it is shaped like this because forest will not be like a rectangle. So also you have a boundary of uh, the illegal construction in around a city. So for example, this is a city and people have created illegal constructions in this part of the city. So here they have created illegal constructions, and also they have created some illegal constructions in the forest zone. So now you are given a case where you have to find out the zone that is forest zone and has also been occupied by the illegal construction people, uh, building constructions. So as you can visualize it, that this is this part. So, but uh, having a look of it is that you are able to understand, but we need to perform operations in QGIS or in GIS softwares to separate this out so that we are only left with this region and the else is removed. So what happened was we were working with more than one vector layer, that is this, and we tried to analyze based on their interaction and applied some operations for our understanding. So we got out this part. Maybe your use case is different. For example, your boss tells you, go and make me a drawing of the area, which includes Pune city as well as the surrounding forest area, as well as the. So this is Pune city and this is the surrounding forest area. Now, your boss wants a complete file of it, the overall boundary. So you will work on it and you'll give a overall boundary. Okay, boss, this is the final output and it looks like this one. So the final output will look like the blue one, not. So there was a interaction of two vector data and you created your output result by your law of rule, by your analysis of it, that what you wanted from it. Okay. So this can be performed, this kind of interactions can be performed in vector data as well as raster data. So this is called as, when we are working with more than one data, one single vector, that is two vectors, can be three, not one. When you're working with one, that is different. When you're working with more than one, it can be two rasters, it can be a combination of them, but, but this, that is called as overlay analysis. So I think if you are clear with overlay analysis, or are you clear with overlay analysis? What the definition means, right? Just let me know. So now we'll talk about it in detail. So I just gave you an overview of the definition of it. Now, overlay analysis, it can be vector based, it can be raster based. So we need to understand both of them. What kind of them are to be done in vector? What kind of them can be done in raster? Now, for our understanding, if you have, maybe if you have a slope raster, or you can have a slope vector. If you saw the bands in Landsat, so you had a band. Similarly, you have a raster for slope also. It can be in vector form also. So if you have different layers, and when you combine it to get something useful out of it, as the two examples I just gave of the analysis, so that is called as overlay operations. Now, if you talk about vector-based overlays, so there can be three kind of vector-based overlays. One is point in area, one is line in area, and area on area. So Now, let's talk about point in area. Now you had, for example, you had these three trees. Now, one of them was the tree A was a tree of elm. The tree B was the tree of maple. And tree C was again elm. And you have land cover area. So one falls into the rural area, that it is the part of some village, and two falls in some urban area. So now you have two vector, one is points and the one is polygon. Okay, one is these 3 points. Do not consider this outer part. This is just for reference. Now, these three, and when you overlay, when you overlay this over this, now the information of your points increases, because now you also know that A and B are in rural area, whereas C was in urban area. So such an analysis is called as point in polygon. Then we go to the next one, that is uh, line in polygon. Now, for example, there was this street, there is this road, it is a highway. I'm just giving an example. Maybe let's, for Indian reference, maybe let's not call it rural, let's call it state. Whereas this one, let's call it central government, the national highway, that is C or N. So when I know these three roads and I know now the land cover, when I overlay this into this, now I know my A falls into my S. That is, it falls into this zone. So this would be a state highway, whereas this goes here, so it would be a national highway, right? Now we just understood point in area, line in area. Then there is area on area. Now now I have provinces. For example, one is maybe Chandigarh, two is maybe another city, Ludhiana, three is another city, uh, maybe you can call it Patiala. So Chandigarh, Ludhiana, Patiala. And land use means what is it? The type of what the land is being used on ground for. For example, A is residential area, B is industrial area, C is some other kind of area, maybe agriculture area, and D is maybe dairy, like uh, for milk products and everything, maybe that kind of area. So when I overlay both, now I see that in Chandigarh, I have in this part of Chandigarh, I have small part of the dairy area. In Chandigarh, I have a small part of the dairy area. I have this residential area. So you have now much more information about your data. So similarly, just give it any class. For example, this is also example of polygon to polygon. Maybe this is Canada and this is USA. So uh, maybe this region is the region uh, which has gold mines. Okay, you have gold here and you have copper here. So now you know that for Canada, you have in this particular region, you have gold, and in US for this particular region, you also have gold. So it is the kind of analysis you do from your data. Now you understood the vector operations. Now there are some operations. Also, these are part of these vector operations. So you can see in polygon to polygon, right? Now, if you have this, maybe your like the one I said, like if this is Pune and your boss said, find me Pune as well as the adjacent forest area. Now you give him a combined file. Or if he says, in Pune, find me the forest area. So you intersect it. That process is called intersect, and you give him only this file. Similarly, there is identity feature. So what it does is in the first file, what part of the other file lies? It gives you that part. Similarly, there is clip feature. If you have been working with GIS, so I think you will be very familiar with clip feature. So you'll take one polygon and you'll clip among the other. So dissolve. You have multiple polygons. You want to dissolve the polygons and merge it into similar kinds. That is dissolve. Now you have two different polygons. You want to merge it into one, and you have these two files. You want to create a common buffer to them. So you will have a buffer to them. So many of these operations, you can also do it in raster also. This is the intersect one. Now, unlike intersect, there is also a part called the erase tool. Now, in this, if you have two files and you use the erase tool, you want to erase this part. So now your boss says, give me Pune file without the forest area. So you'll use the erase tool. Whereas in the intersect tool, it was the common part. In erase, it will remove that part. Similarly, now what happens is union tool combines all the dataset into one single feature. Uh, Not one single feature. Yeah. So union will combine it into a one single feature, but it will preserve the attributes of both. And when you work on merge, it will also merge the attribute. This will preserve the attributes of this. So there will be many columns. Whereas in this, it will merge the attributes. Whereas in append, what happens is the data two attributes are kind of pushed into the data one. So they are added into the column of data one, not a separate column. They are added to the data one. So here a primary data, the data for importance is needed. For example, you have a shapefile that is river and you have another shapefile that is city. So when you append, your city file will dissolve and it will, this new data set will be river only. So we are done understanding vector overlays. So I'll now explain the raster overlays. In vector overlays, if you have any confusion or anything you want to ask, just let me know. If it was clear, just yeah, okay. So now we do raster overlays. So what happens is when you have a raster, for example, you had this image. So it is an analogy now. For example, this one is from vector and this one is from raster. So now you have a raster which has this pixel values here, and there is another raster image which has this pixel values here. Now you apply the addition operation. So just like in vector, when you apply addition, you'll get these polygons. Similarly in raster, when you add them, it will create like these pixels. So it was 0 here, you added to it, it became 3. It was 2 here, it remained 2. It was 3 plus 2, so it became 5. So similarly, this is one addition operation. It could have been a subtraction operation. It could have been a multiplication operation, or maybe you could add a rule to it, or you could add a factor to it. For example, uh, I want to add twice of these values to it. For example, you multiply every pixel with 2 and then add to it. So it would be 3 twos are 6 here, 6 plus 2, 8 here. 8 here, whereas 0 into 2 will be 0 only. So 0 plus 2, it will be 2 here. So you can also kind of change the rule of law as per your accordance. Just a minute. Now we did Now we understood before point in polygon, right? So there was this polygon, you have these points. For example, this is Pune, this is schools, and your boss is asking for schools in Pune. So when you overlay, you get the result 2 and 3. Now similarly in a raster, you have the pixel represented by the school, or it could be anything. For example, a certain type of crop, right? And this is your city. So that certain kind of crop, when its pixel is added to the city class pixels, now you know wherever the value you have 4, 4, 3. So now in this area, now you know wherever the value there is 3, 3 means there is school. Wherever it is 4, now 4, 4, it means when you look in this whole raster, you look for pixels with the value 4. So you find these two. And now these two means the school in Pune or the particular crop in Pune. Now, for example, I have these two band images. Now, one had pixel values like this, the other one had like this. If I had to just do add operations, 3 plus 2, 5. I will have this. If I had to do subtract operations, I will 1 minus 2, I have minus 1. So I'll just subtract with the corresponding pixel. For example, I use a maximum limit. So I'll find the ones which are maximum. 3 is maximum here, 5 is maximum here. So I'll create a maximum one. Similarly, a minimum one. Similarly, an average one. 3 plus 2 by 5 by 2, that's 2.5. Now I have an average pixel. So now, these were very simple operations. For example, now I add a complex operation. What I say is, I want this is a kind of a Boolean operation. So, what Boolean operation means is, so maybe I have this image, I have these pixels. I have some values here, 3, 2, 0, 4, 1, -1, and so and so and so and so. Now I apply to it a operation where I say maybe when I add a I apply a operation to this raster and I say I want all the values greater than 2. If the values are greater than 2, just make the value in the pixel as 1. Whereas if it is less than 2, if the value is less than 2, just make the value 0. So what it means is either I can just give one query even if I just give this one. So in case if it is coming 1 here, that means if it's true, if the value here is greater than 2, just let the value to come 1. So it is not important for me to give the second part of the query. So these operations are called Boolean, in which we use true and false. So when I will apply that greater than one thing, now I'll get a new image where or a new pixel. Now this is greater than 2, it will be 1. It is less than 2, it will be 0. So this is -1, it will be 0. So I will have an image that is in the value of 1 and 0, 1 and 0, 1 and 0. Similarly, now if I say I applied a condition where layer 1, the value should be greater than 2, as well as in layer 2, the value should be greater than 1. And that is, it is important. So now here in layer 1, at here, the value is greater than 2. Also here, the value is greater than 1. So because this condition is satisfied, it is true, we get 1. At any other place in both, we are not able to get true. So these all come as 0. Now we have another condition that is either maybe layer 1 greater than 2 or layer 2 greater than 1. So many in this case are true. So that is 1 and others are 0. So in a raster, you have three kind of data processing models. Just a moment. Okay. So now we have three kind of raster data processing models. One is called local operation, one is called neighborhood operation, one is called regional operation. Just like the one we had point in polygon, line in polygon, polygon in polygon. For raster, we have because of the pixels around the pixels, how there is a in polygon we were just in vectors we were just restricted to the property that it is a line, a point, or a polygon. But here in raster we have pixels, so we have a added possibility that while processing we also kind of use the combination of pixels in processing. So what that means is I'll explain. So just as I said, for example, I have a raster, that is I have an image, or I say for for values between 1 and 3, just make a value 5. For values 3 and 7, just make a value 3. So uh, this is called as reclassification. That that you are giving it a new rule to understand. So this is a local operation that you're choosing some pixels and you are reclassifying it. So, for example, now I know that uh, certain crops that have that are giving reflectance value as between 1 and 3 are the same crops that are between 8 and 12. So reflectance of 8 and 12 is also like they are the same crops, but they are matured crops, whereas in 1 and 3 they are just grown crops. So, but you know this that they are the same kind of crops. So, or you did field survey that you saw that the values where you have 8 and 12, you saw that it is also sunflower, whereas in the field you saw that where you're getting 1 and 3, it was also sunflower. So you classified them as a common new value. So now you know for in your reference that 5 is sunflower only. So you could give it a new outlook of the raster, the new outlook to the image or itself. So this is called as reclassification because you are working on each pixel based on a rule that you are setting for it. So it is called a local operation. Just ignore this one. This is Boolean, as I explained here, like and or. So this is for you to understand if A and B. So that is the this part because it satisfies both condition. It should be A as well as B. So it will be true here, false here. So if you are working in raster calculator and you have to apply some operations, you will click this one, raster this, polygon this, and the raster or polygon this. Now A or B, A, X or B, that is neither of that, it should be neither A, it should be neither B. So in that case, this one, you use this one here. Now it should be A, but remove the part B from it. So you'll use this symbol. Now we talked about local operation, that is kind of reclassifying it. What if and the next thing what we do is local neighborhood. Now what that means is, now you had these two vectors. Now you want to apply some operations on them. But to apply these operations, we have certain rules that you need to consider your neighboring values also. In reclassification, you were not concerned about what the value is here, here, here. You were just concerned about the value, what is in the box. If it was 3, you called it 5. So you were not concerned about the values that were adjoining. But here, you have to be concerned about the adjoining values. Now, that is called neighborhood operations, local neighborhood operations. Now, if I apply a rule that a new pixel value should be the sum of the original value plus all the neighborhood values. For example, it was 1 here. So I will add all these values to that and make a new pixel, right? So that is called as neighborhood operation. It is not restricted to just the adjacent neighbor. You can take as many as, but it is for your use case. It is for your understanding how to do it and why are you doing it. Maybe at this level, if you are new to JS, you will not be able to apprehend that why are we doing this, where this will be useful. But when you go deep into raster functions, understanding how certain layers of rasters interact with others, then you will understand how this is performed. So This is almost the same. Now we have the regional operators. After local neighborhood, we have the regional operators. Now, what regional operator means is just uh, to explain this, I would maybe use this one. Yeah. So, for example, you have one raster layer which has a defined classes here. For example, uh, this is Chandigarh. This is, or maybe you can say, this is a certain kind of crop. This is a certain kind of crop, and this is a certain kind of crop. Now, you have another raster which is having the value of sunshine that the area gets, the sunshine that each area gets, or maybe not sunshine, you can maybe call it precipitation data. Yeah. So these were the crops, and below here you have the precipitation data, the amount of precipitation that is happening over each pixel, the average of it. Now, you defined a zone based on this, that you're concerned about these crops here. So it has a zone to it. You're just concerned about this, and this. So that concerned, when you and interact it with the precipitation layer, and then the final value that comes out is maybe you give your green ones a value 1 or something different. So when you added that value to that value, so you can analyze that this is different. So here now you can figure out for your zone what is the value of each precipitation, or you can average out the precipitation value for the whole region. So this is regional operator. So it depends more on the region. It is not just based on the neighborhood. It can be like a part of this. So you can see like we perform three operations together. Whereas in neighborhood you have to first it will be performing pixel wise on the neighborhood. But here simultaneously there were three different regions. So that is regional operator. Uh, it may feel like that we are going into deep into mathematics or something like that, but uh, you just need to understand the overview, because this will form your basics when you will maybe later on trying to do some Python operations, some automations, how to what operations I should apply on my raster layer. So these form the very basic of your understanding about it, right? So for example, I chose the zone here. I had some value here. So this was added to this. Now I have clarity in my zone that in my particular zone, I have this pixel's value. In my other zone, I have this pixel value. So the last one is map algebra. So what map algebra means is it is kind of a uh, it is not like a different subdomain of it. It is a combination of it. So it is just like using mathematical operations in any form. So for example, you just use basic addition. So this layer you had, this layer you had, you just performed basic additions. So maybe you performed the just like in the local neighborhood, you just performed an operation where you added all of it. So this is just a combination that you're applying algebra or mathematics to all three of them. That is why they are possible. So in QGIS as well as ArcGIS, we have raster calculator. Now, for example, I have three different kind of layers. Now, in this layers, I can do the expression here. For example, if you remember in NDVI, what we did was uh, NIR minus red by NIR plus red. So it was kind of a overlay analysis. So we performed the pixel addition subtraction, if you remember. So that was a overlay analysis and we got the NDVI values. So similarly, we can perform different, like based on our requirement. We can use it as we want, the way we want. Now there is two, three very important overlay approaches in raster, and they are little bit complex to understand, but these are approaches. What we understood first was methods. So approaches is a combination of all of them. So first we talk about weighted overlay. Now just so these are important for you to remember. What is weighted overlay? What is weighted sum? What is fuzzy? So there is these three. Now just let us remove this. Now I apply an operation whereas in which I say let's classify all the values that are equal to 0. They should be 0 only. But anything that is 1, it should be 3. I am not multiplied it, I am classifying it. For example, if there is any value that is 2, I say just call it 4. So that is my classification. So in weighted overlay, just mind my words and remember it. In weighted overlay, first we classify the image accordingly. So we had two rasters. Maybe this was the soil type and this is the precipitation. So kind of uh, we kind of classified into a common uh, term first, but uh, like how to explain this in few words. Our main purpose of weighted overlay is that at the second step, the two images that we have, their pixel classes should be of the same units. For example, if there is a 3 in here, that 3 should also mean the same, the 3 here. So it should not be different. Whereas initially you had something different. Now you classified it. Maybe there was this soil type 1 and you call that soil type as 3. And now you know that precipitation for that soil type, you understand your precipitation for some soil type, is it good or bad? Based on your interaction of both, you have an understanding and you give it a class. Okay, for your understanding, that 2 is similar to the 2 of it. 3 means 3 of it. Like the precipitation here for 3 is what is good for the soil 3. Then you do an operation. It could be plus, minus, or anything. That is called weighted overlay. You just remember the word, you reclassify. Do not try to get into understanding like what it means here. Just remember, in weighted overlay, what you do is reclassify. First you reclassify, then you apply the operation. Now, then we have, so Also, in what this word weigh means is, uh, just giving an example. For example, there is a person who weighs 70 kg and there is a person who weighs 30 kg. Now, when they both will stand in a same measuring, maybe this is a measuring pot. So I'm measuring the weight together. So I find that they are 100 kgs. Now I say that this person has 70% influence in this output, right? And this person has 30% output. Now I define a new case where I say, based on their weights, I give them food. Uh, Now I see that uh, so per kg I give the person two, 2 kg of food. So now this person will be having 70 into 2, that is 140. And whereas this person will have 60. Now I define a new weighing scale where I just measure the food. And that weighing scale was based on this one. So I defined it giving a multiplication factor. So I said here it is now 140 and here it is 60. So just try to understand, maybe this was a pixel before and this was a pixel before. So I had to do an operation where I got a new pixel, but there was a influence 70% of this. Like there was a multiplication factor of 70, whereas here it was a multiplication factor of 30. So there is a influence to it, which is kind of how your final result will be, your multiplication factor. So now what I am doing is, so here I have different values of pixels. Now I want the land use to have 40% influence. So whatever the pixel value will be here, 40 into that value, 20 into that value, 40 into that value, this total forms 100. So the final value will be that. So I have applied a weighted addition overlay. So this weight is kind of influence, the percentage it matters. Similarly, after weighted overlay, we have weighted sum. So in weighted sum, what we do is we do not classify it. Whatever we have the uh, original value. So I had this original value. I'm not classifying it. I'm just giving the weight is like the importance to it. So this matters to me 25%. This matters to me 65%. So I multiplied this with this and now I have the final value. I've not classified it. I took the raw value and I made it into this. And then maybe I did addition or anything. I can do multiplication together. So I get this final result. So then there is a third type, which is called fuzzy type. So what happens in fuzzy type is, Now you have a pixel here. So they are based on probability. So now you have a different kind of raster where you have a probability index. For example, the probability for potato to grow in this pixel. Now you will understand, like, when you go into deep uh, studies, so you will somehow uh, you will create future prediction maps. Prediction of will there be storm here next year? Prediction maps. So, like, we do prediction, okay, tomorrow there will be rainfall. So there is probabilistic prediction. So for maybe next year, I say there is a good possibility that this soil can be used for growing potato. So maybe I say the probability that it will give good potato is 80%. Though it depends on us what we sow, but there is a probabilistic map. So that there is a 80% probability if you sow potato here, it will be good. So maybe if you sow in this pixel, if you sow uh, maybe sunflower. So the probability I say is low because of future prediction bias. I say it is low that there are 40% chances if you grow sunflower here, it will, there is chance that 60% chances it will die, 40% is it will grow. So now I combine this data. There can be like many other plants and everything. So I combine this pixel data and I get a combined pixel. Now, when I click at that pixel, now I will get to know, okay, it has 80% chance for this potato, 40% chance for. So when there is probabilistic distribution data in a pixel, so that is called as fuzzy. So fuzzy logic is very extensively used with machine learning and AI to uh, understand crop patterns. So if you're new to it, just don't worry that if it has just gotten too complex for you in this today's class. But if you keep on studying it, like if you remember when you started studying trigonometry or algebra, it in school it must have been like a little, when you started it, you'll be worried like what is it? But as you grow into it, they'll form like the very basic concepts to your knowledge. Now, if you want to just explore uh, fuzzy logic applications in crop prediction. So there are many examples. Fuzzy logic approach for. So this is kind of getting multiple probability from a single pixel. So as we were talking, if there is a query and someone says, is it cold? A yes means like 1 or 0 in the pixel value. But if it is cold, if you go using the fuzzy logic, you have a probability. It says very much 0.9. It says little 0.25, very less 0.1. Though uh, this is a little wrong because the addition should be totaling 1. So maybe there is some error in this, but we'll do some Maybe next time we'll, so in this class, we'll do some overlay operations, and also we'll do this exercise, and also we'll try to create land use map with overlays. So in the next two classes, we'll be covering this all part. Today was more of a theory of what is overlays. So I would suggest, if you want to excel in Python operations, like there is a company called SatSure. So it works with crop classification highly with Python. So if you go there, you have an interview and you are very strong with fuzzy logic, so you can crack the interview. So these things will be used when you go to automation. And uh, if I see in your volume, so just like NDVI, you will be able to calculate such operations. In R, it will be very used. In R, it can, so the same methods can be used in R. Okay, so I think for today, I went too complex, but if you have any doubts, or if you want to just go and repeat the lecture and then ask me, you can always write an email to me, always uh, write in the group, or you can always personally message me your doubts. So that is never a problem, because you should not keep your doubt, because doubt build into a big problem. You'll keep a doubt today, when you'll be working with that in future, so it will become a big problem. So just don't keep doubts to yourself. And in case you were not able to understand some of it, just try to maybe rewatch the lecture, maybe, or try to explore some um, videos. And if still you were not able to get it, just let me know. I can repeat the part, no problem. So for today's class, please, if anyone has a doubt or anything, just let me know. I mean, the doubt may come up with time. That is not a problem. But until now, if you feel okay, you need to ask something, or is it okay for now? Sir, can we do practical case example? Yeah, yeah. We'll be doing it. No worries. Uh, Maybe fuzzy is a little complex for us to do in the class right now, but we will surely do weighted overlay, weighted sum. Yes, we'll surely do that. And I will try to, maybe, if possible, we'll do the fuzzy also. Anything else? Okay. Okay, then I hope so we'll end the session today here. And if anyone, so please, I understand it could have been very complex today. So if you study it a little, if anyone has any doubts, just message me. Or uh, in the coming classes, we're going to do practicals about it. So the things will get more clear. Okay. Okay, then I'll end the session now.